Hi everyone, in this video we will look at how to use double integrals to find surface area. So in particular, let's start with a problem in mind, which is we will have a particular surface that's given to us. The equation of the surface is always z equals f of xy, and we will have some region in the plane D, and the question is, if I take this region and I project it up to the surface, it's not going to look exactly like this triangle. It will look like this pizza slice here. And the question is, if I have a surface and I have a region D, can I find the area of this part? That is the area on the surface that corresponds to the given region. And it turns out you can, and the area of the surface z equals f of xy, as long as the partial derivatives are continuous, is given by a double integral over the region D of fx, the partial derivative squared plus partial derivative y squared plus 1. Recall this is very similar to the arc length formula that you've seen in single integral, and it is all because of the same reason. We will see the reason behind this at some point later. But for now, we're just going to look at an operational way of finding this. We will look at one example, the area of some surface x squared plus 2y plus 2 that lies above the region T, where T is a triangle with the vertices 0, 0, 1, 0, and 1, 1. So the nice thing about this particular way of finding the area is we don't actually have to know what the surface looks like. What you have to keep in mind is that this is actually like it's in reality this is what's happening. It's a three-dimensional thing happening here. So there's this region and it's getting projected up to some surface, and it sketches us, and we're finding the area of this particular region in the surface. So in order to find that, we need the partial derivatives. Partial derivative with respect to x is just 2x. Partial with respect to y is just 2. So the double integral is simply square root of 1 plus 4x squared plus 4 dy dx. And this equation is y equals x. So this goes from 0 to x and goes from 0 to 1. So what we have is 0 to 1 and a 0 to x square root of 4x squared plus 5 dy dx. The first integral, so again here it's important to have the order dy dx so that when we integrate I will have an x for x squared plus 5 dx, which is perfectly set up for me to use u substitution. If I go u is 4x squared plus 5, du is 8x dx. X dx becomes 1/8 du, and I get 1/8 square root of u du. When x is 0, u is 5, and when x is 1, u is 9. So you get 1/8 u to the 3 halves, 2/3, 5 and 9. The 2 cancels out, get a 1/12. 9 raised to 3 halves becomes square root of 3. Now 9 is 3. Cube is 27 minus nothing like that happens with this. So it's just 5 square root of 5. And that's the surface area. You can do the same thing for this particular given example here and try this out. So try out, and again this is going to be extra credit. And just like other extra credits, you can email me your solution. So just work on paper, take a picture, email it to me. Shouldn't take long. That's it for this video. Surface areas are pretty simple, and we will be seeing them in some different forms at a later point as well. That's all for this video. Thank you.